Is it recording? Let everyone know they're being recorded. They know. Okay. So now this one, I think it will be a very short one where you are getting information from the graph. It's very important that when you are given a graph, you are able to see the information. For example, in grade 12, 10, 11, they'll give you a graph and you'll be able to read from it. That's what they're saying. Now, the values of a function, right? The domain, the range. Are you able to find the domain and the range from the graph? Comparing function values, solving equations and inequalities graphically. Increasing and decreasing function, local maximum and minimum values of function. So these are the objectives that we need to know here.
Sharing the screen.
Ma'am,
Ma'am, we're not seeing anything.
Oh, sorry. Okay, let me share. So I'm saying in this section, this is what you need to know. These are the objectives that you need to know. Values of a function, domain and range. Are you able to find the domain and range? Solving equations, and inequality graphically, guys. Increasing and decreasing function, local maximum and local minimum values of a function. They say many properties of a function are more easily obtained from graphs than from the rule that describes the graph, the function, meaning that y is equals to x squared as the equation. It's not easy to obtain a lot of information, but when you draw it, it becomes easy. We'll see in this section how a graph tells us whether the values of a function are increasing or decreasing, and also where the maximum and the minimum values of a function are. So let's look at the values of a function, the domain and the range of a function. So a complete graph of a function contains all the information about the function, because the graph tells us which input values correspond to which output values. Now, to analyze the graph of function, we must keep in mind that the height of the graph is the values of a function. So you can read off the values of a function from its graph. Does it make sense what they're saying? Yes or no? Guys? Okay, I'm assuming it's a yes. Silence means concern. Now, here's an example. They say the function t, graphed in figure 1, gives the temperature between noon and 6 p.m. at certain weather stations. Can we all see that? Now, the first question says, find T1, T3, and T5. Can we do that? T1, T3,
Yes.
and T5. What is T1? We are reading values from the graph. What is T1?
Temperature
25.
So T1? 25. Okay, let's do that. So T1 is equals to 25. T3 is equals to what?
30.
30. T5 is equals to what?
20.
20.
Thank you. Now let's say which is larger, T2 or T4? Nice.
Let me mute her, ma'am. I'll mute her
Darling.
first.
I think maybe removing her because the baby is needs her attention.
Yeah, clearly.
Is it Tibello? Is it Tibello?
Yeah, it's Tibella. Okay, let me look for.
Yep. Please disable a mic and yeah, the baby needs attention. She's the independent variable in this case. So there's nothing we can do. Now they're saying which one is larger between T2 and T4? Between T2 and T4, which one is larger?
T2.
T2.
Let's see.
It is larger.
Well, okay, T2 is larger and T4, because we see that T2 is what? 35.
25.
Okay. And then they're saying, find the values for which values of x for which t x is equals to 25. What are the values of x?
1.
1
Let's see.
and
They're
1
saying
and
1,
4 and 4
1 and
1 and 4.
well
1
done.
and 4.
Well done. Now find the values of x for which tx is greater than 25.
T2
T2.
1. X is greater
Wait,
than
wait,
1.
2 and
Less
3.
than 4.
T2 and T3.
No,
it's 2 and 3
no.
1. X is
T2
greater than 1 and less than 4.
Well done. Is it
But ma'am,
included? Let's go.
there was the included. Yeah, there was the included.
Thank you. Are we all together?
Yeah.
no
Look at this.
Yeah.
Between 1 and 4. Find the net change in temperature from 1 to 3 p.m. I am going to pinch someone. I'll pinch you. If you don't get this one, I taught you. The whole class will get a beating. Or a zippering. What do we do here? The net change in temperature.
isn't it that from no.
Yes? Guys, so if this was an exam, you were not going to answer the E. Yes.
Ma'am, oh wait.
The first person who said ma'am. Yes, the first person.
He said the temperature that is found in 3 p.m. minus the temperature that is found in 1 p.m.
Well done. Do you remember that net change I said last time? And I even talked about bread.
Yes, ma'am.
So you say the net change between that, it's the temperature that you find in 3 minus the temperature that you find in 1. So let's see, the temperature we find in 3, it's 30, minus the temperature we find in 1, it's 25. So which is 5. Then there has been a change between, what's this, between 1, the temperature was 5, I think degrees. What did they say? Fahrenheit. Yeah. So there was a change of 5 Fahrenheit. The Fahrenheit. Yes, that one. Between 1 and 3. That's called the net change in temperature. Are we sorted now with this one, guys?
Yes.
Thank you. So let's see. Oh, yes, we are right. Oh, yes. Our answers are right. Oh, yes. The height of the graph is 25 when x is 1 and when x is, in other words, between 1 and 4. Then that's where the temperature is higher. Oh, yes. Guys, we are doing this. Guys, you see? This is how we should be thinking. Now, the graph of a function helps us to picture the domain and the range of a function on the x and the y's as shown in the graph. Remember when we had a parabola and we were able to see where the domain is and the range is? First class. Yes. So now they say the domain and the range from the graph. If you look at the following graph, the domain and the range of the function y equals to f of x can be obtained from the graph of f as shown in figure. The domain is a set of all x values for which f is defined, and the range is a set of all corresponding y values for which the corresponding y values. If you look at that, do you see here there's no graph here? And after this dotted line, there's no graph. So meaning that the domain is between from this point all up to this point. So the domain is between here and here. And the range is between here and here where the graph ends. This is the range. That's how you look at it. Same applies to how we looked at the parabola. We said the parabola is like this. And we have a 4 here. We said, how do we look at the range? We said the x values, all the x values if we draw lines like this, we can see all the x values. And remember that the parabola continues like this. Like this. So all the x values, that's why we said x is an element of real numbers. Now, the range, we went and said the y values, where does it start? It starts at 4 and it cuts up to infinity. So that is y greater or equals to 4. That's what we say the range is. Can I move forward? Do you see that maths is continuous? What we did, we still continue doing. Thank you.
Yeah.
Now, because here they say use a graphing calculator, we'll not use graphing calculator, so we can just keep this example and go to comparing function values, solving equations and inequalities graphically. I know most of you didn't get this question, including me in grade 12. That's why I didn't get 100. Tell me if I'm lying.
Some of us did, ma'am.
Ma'am, the 100 didn't come from inequalities.
Not inequalities. Look at the
Not
question. It says,
inequalities, something else.
look at this question. It says solving equations and inequalities graphically. I know that 2 marks you didn't get it. Most of us didn't get it.
Is it
Should
where,
we
ma'am?
go to it? Yeah?
Is it where you have to sketch your own graph at the side?
No, it's where you have a graph and they tell you where f of x is greater or equals to 0. Find the values of x for which x greater or equals to 0.
Question 1.
Most of people didn't get it, and even most people are still not getting it even now when it's being marked. Not question 1, from the graphs, guys. Let's go and see what I'm talking about and not debate. They say we can compare the values for which 2 functions, f and g, visually by drawing their graphs. The points at which the graphs intersect are the points where the graph of the values of 2 functions are equal. Remember when they say find the point of intersection?
Yes.
It means that it's the point where the two graphs are equal in x and in y. Those points. That's why when you were solving that, the point of intersection, you equated the 2 graphs or you subtracted one from the other.
Yes.
Does it make sense?
Yes.
Yes, ma'am.
So they say, so the solution of the equation was this one. Are the values of x at which the 2 graphs intersect? The points at which the graph of x is higher than the graph of f are the points where the values of g are higher than the graph of values of f. Does that make sense? Does that statement make sense?
Yes, ma'am.
Yes, ma'am.
Now they
No.
say that. Okay, since it doesn't make sense, let me make it senses. So they say the solution of the inequality this. They're not saying solve the inequality. They're saying use the graph to solve f of x is greater than g of x. Do you remember the question now, if you got it in grade 11 or 12?
Yes.
Thank you. Let's sort that one. Good. So they said, so the solution of the inequality f of x less than greater are values of x at which the graph of g is higher than the graph of f. Does it make sense, or I need to go deeper?
It makes sense, ma'am.
Go deeper.
Okay, let me go deeper.
Oh, deeper, mama.
Yes, definitely. So okay, now in maths, remember that we said the height of the graph is, when you're looking at the height of a graph, you're looking at the y-axis. Are we all together?
Yes, ma'am.
Yes.
So if I call this graph, let me call this graph. I'm calling this graph g of x. And then I come and draw another graph. I call this graph f of x. Are we all together?
Yes, ma'am.
Now, if I say to you, find f of x is equals to g of x, what do I mean?
Point of intersection of the two
Yeah.
graphs.
Wait, the x
Two
values and the y.
intersection where both graphs are equal.
Yes, I want the values of x for which way graphs, both graphs are equal.
Equal, yes.
Does it make sense now? Now,
Yes.
if I go, I want the values of x for which the graph are equal. If I go to my graph, if this, let's say this was -5, right? And let's say this was -3, and this is 1. And let's say this x value is 2. And then let's say this x value is, for example, 3. Now, then you say x is equals to -5, x is equals to -3, x is equals to 1, x is equals to 2, and x is equals to 3. Do you see that? That's where the two graphs are intersecting, are cutting, or they share the same points. They share the same point of x and they share the same point of y. Does it make sense?
Yes, ma'am.
Okay? Now,
Yes, ma'am.
let me put, can someone read this? Because I noticed the inequalities are beating us.
F of x is greater than g of x.
Thank you. Now, when you're talking about greater, remember, in a Cartesian plane, right? In a Cartesian plane where these are y's and x, if I stand here and you stand below me, but we all have the same values of x, you are less than me. Does it make sense?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Same applies if A is here and B is here. Which one is higher? Which one is higher up? Is this one. Do you see that?
Yes.
Is greater than this one in the Cartesian plane. Are we all together there?
Yes, ma'am.
Now, if they say find the values of x for which g of x is less than f of x, you go and check where is my graph g of x? I mean, where is my graph f of x on top of g of x for the same value of y? Am I making sense?
Yes,
Yes.
So
No.
if I go here, let me take a highlight. Where do you think it is on top? Remember,
Between
from maths, we
-3
read from
and
left
1.
to right. So it's what?
Between -3 and 1.
Between -3.
Ma'am,
-3
wait,
and 1.
ma'am,
No, yes?
what you say, where it's -5 going downwards.
Yes. Remember,
Yeah.
we read the
Ma'am.
whole graph. We are reading
And
the
less
whole
than
graph.
-5.
Yes, we are reading the whole graph. For this value of x here, if I draw a line, remember this graph is continuous like this. If I draw a line, which one is on top? The green or the purple line?
Purple.
The purple line. And in this case, the purple line is our f of x. Do you see that? So meaning that point is included. Even this point is included. The x value here is included. Even the x value
So
that
graph
is
of
here is
infinity.
included. Up to this point here. Do you see that? Up to 5. Do you see that, guys?
Yes.
So meaning that this is true for, you go and write here. Okay, give me a sec. This is true for x from -infinity to what? To 5. -5. But because there's no inclusion here, like this, you don't include it. Because inclusion meaning that f of x is the same as g of x. Are we all together there?
Yes.
There's a heavy breathing.
Yeah.
What happened? Okay. So now since there's no inclusion, it means you're not going to include it there. Are we done?
No,
No.
ma'am.
Yes.
No.
We're not.
So-
So we go further. If I draw a line here, is my f of x greater than g of x?
No.
No.
Then I go, I get to 3. Look at the 3. What happens?
F of x is greater than g of x.
Do you see that for the whole part here, f of x is greater than g of x?
Yes.
So then you say between -3 and 1. So you go. Or between -3 and 1. Are you done? No, because you have to read the whole graph. And you see, no, this one, because my graph is, no. Hey, son, here, there I am again. Between 2 and 3. So if I take this out of the exam, we are all sorted now.
Yes, ma'am.
But ma'am, if I may ask, between 2 and 3, isn't g of x? Oh no, it's not greater. I thought it's greater. No, sorry.
Thank you. Thank you. Do you see where g of x is? Is here. After that, g of x is always on top here. And then f of x is at the bottom there. That's where you stop. Like this.
And you know where my struggle is?
Mm.
The included and not included part. That's what I don't understand.
The included part, they just mean that those two are equal. Do you
So if
understand?
they're equal, because of the restriction, I don't put the equal sign.
If you include there, you are saying that f of x is equal to g of x. You want points where f of x is greater than g of x and f of x is equal to g of x. And we know that at f of x is equal, here it's and. They're equal. They're equal. They're equal. They're equal. They're equal. Do you see that?
Yes.
So you are saying from here to here, my f of x is greater than, but when it comes to -5, they are equal. So then you put equal here. At -5, they are equal because you included there.
Okay.
You see that? You guys need to explain to someone. And remember, when you explain to someone, if you don't know how to explain, don't say I taught you. Don't mention my name. Does it make sense? Because the grade 12, then I will come to you. Or 10, 11. Does it make sense now?
Yes, ma'am.
Yes, ma'am.
Thank you.
Yes, ma'am.
So let's do one
Yes,
last
ma'am.
one. I like doing this because I know it's in the assignment. If not in the assignment, it will be in the exam. Okay, so let's look at this. Okay, I'll use a different color. There's one that says f of x is equals to there's one that says f of x times g of x is less than 0. Do you see that one? Let's put
Yes,
less or
ma'am.
equals to 0.
Yeah.
Okay. You know how you do that one?
Yes, ma'am.
Okay, can
Yes,
someone
ma'am.
explain how do I do that one?
Yes.
This one basically explains that you're using the signs of the y-axis. Yeah, the y-axis. So there's a positive and there's a negative. So whenever they say f of x times y of x, they mean the sign. So the graph is lying in the negative side of the y-axis is times the y-axis that is times with the y-axis. I'm not sure if I'm making sense. Got that? Yeah.
I think you're making sense to me. Are you making sense to anyone else here?
I didn't hear anything.
Yes.
Kind of.
We heard you.
Okay. Lalelani,
No.
listen. Okay. So f of x times g of x is less or equals to. What do we know about less or equals to in maths?
Included and
What will be the sign before that? Less or equals to negative, right? So now if If we go to negative times negative, negative positive times positive, positive times positive, we are timesing here. So what do we need? What do we need? Which one do we need so that the answer is negative? We need.
A positive and a negative.
Thank you. We need a positive and a negative, meaning that it's either we want our f of x to be negative or g of x to be negative. Positive. These are the two options. Or we want our g of x to be negative and our f of x, not or, and. These are the two options. Do you see that? Guys?
Yes, ma'am.
So meaning that if we times g of x and f of x, it's negative times positive, it gives us negative. Here it's negative times positive, it gives us what? It gives us positive. We also want the point where we take the one of these values, when we times them, they give us 0. Because it says equals to 0 here. So how do you go and do that one? So let's explain it. Remember, we said we want one of them to be positive and the other one to be negative. Do you see that? Now, if I take the x value, let's say this x value here, right? If I take this x value here, will this x value form part of what we're looking for?
Yeah.
Hmm? Guys, think.
Can you repeat, ma'am?
I'm saying if I take the x value here, let me choose a blue color. If I take the x value here, this x value, is it included in what we are looking for? This x value here. Is it included in what we are looking for? Why?
Because there's two positive.
Thank you. Because this value here of y in this graph is positive, and this value of here in this graph is positive. And we know positive times positive will be greater than 0, isn't it? So that's why it doesn't, please mute. That's why it doesn't satisfy this. Do you see, guys? Are you seeing what I'm talking about?
Yes, ma'am.
Yes.
Yes, ma'am.
So meaning that,
Yes, ma'am.
for example, okay, let's erase which one doesn't satisfy. For example, this part, both of them are positive. There's a positive, positive. This whole part, both of them are positive. So we erase this part. Do you see that?
Yes, ma'am.
Does it make
Yes, ma'am.
sense? Yeah, only up to here. We erase. Do you see that? Because this one is positive and this one is negative, so this part is correct. Here, we raise up to this part. Because this one is positive and this one is negative, so this one is correct. Here, this one doesn't even come. Because both of them are negative. Negative times negative is what? Is positive. From here, this one and this one, they do. So it's these, this is what we're looking for, and this is what we're looking for. From here to here, we erase. So meaning that the negative, this function is negative, and this function here is positive. This function is positive, this function is negative. If you multiply them, they give you negative. So what x value is this one? Look at this. What x value is this one? Let's say this is negative 6. Then you say from negative infinity, x to negative 6. Does it make sense, guys, how it works now?
Yes, ma'am.
Ma'am,
Thank you. Yes?
can you just say x is less than negative 6 only without including the negative infinity?
You can say that because we know x is less or equals to negative 6. Then you know that that's negative infinity. You can write it like that for now. You can write if there's nothing that side. And then you come and check, okay, because this one is negative, positive, this is negative times this one. Positive and negative, they give me negative. So from here to here. And this is included because remember the 0 is included. I think I have made it a clear. Otherwise, you can always ask later. I think we are all sorted now on how we read this from the graph, guys.
Yes, ma'am.
Thank you. So this is what they're explaining here. They're saying this point and this point here, that's where the graphs are intersecting, right? And because this graph here is above g of x, therefore the graph of g of x is greater than. That's what they are writing here. The graph of g of x is greater than f of x because f of x is at the bottom on this particular interval. Are we all together there?
Yes.
Thank you. Solve the given equation or inequality graphical. Should I give you 2 seconds to discuss it while I drink my water? On how do we do this? Guys?
Yes.
Okay, I'll
Yes,
give you
ma'am.
2 seconds. I think I
Okay.
didn't lock the meeting. That's why people are trying to enter. Let me see. Lock the meeting. Thank you. Okay, please discuss it and then tell me what's the first step. Okay, you're not telling me I'm coming back. You need to say the first step is this, the second step is that, the third step is this, and then we start solving it.
First step we are going.
2x squared plus 3 minus 5x plus 6. That one is equals to 0. Equals to 0. Then you take 3 minus 6 because 6 is going to change the sign.
Don't you don't you say 2x squared, take the 5x to the other side and take the 6 also to the other side, so it will be 2x squared minus 5x minus 3 is equals to 0. Then you factorize. Yeah, you factorize.
So basically,
Yeah.
do we use quadratic equation?
Yeah, you can.
Yeah.
You can. Yeah.
Guys,
Use
but
that.
didn't they say solve it graphically? Like, don't we draw the graphs and then
Yeah,
check
I think
where
we
find
the
draw
out.
two
the
graphs
graphs.
are equal?
Yeah, you
We draw
first
the
find
graphs
out
on B and C.
Yeah, I think we need to first draw the graph for A. You need to first draw the graph of 2x squared plus 3, and then draw the graph of 5x plus 6. Then find out where the two graphs intersect, because the first one says equals to. And then for B, we do the same thing. Draw both the graphs, but see where the first graph is less than less or equals to the second graph. Just like that. So with C as well, I think that's how we do it, because it says graphical. They didn't say we must solve the equation.
Okay. But like, what about B
Okay.
and C?
Same thing, but it says less or equals to. So we're gonna see where the graph of 2x plus 3 is
So aren't
below
we allowed to
the
evaluate?
graph of 5x plus 6. You understand me? Below or
Aren't we
equals
supposed?
to.
Oh, I understand. So we're not supposed to evaluate.
No. You draw
Okay,
both
thank
the
you.
graphs and then apply the inequalities and the equals to on both those graphs. The way we've been doing with the previous example.
Okay.
I come back. Are we happy?
We are cycling.
Kind of.
Yes.
Okay, so if you went and then wrote on a piece of paper equals to, and then you transpose x to the other side, you are wrong. It says graphically. So meaning what you need to draw, you need to draw the graphs for all these questions. Are we in the same boat?
Yes.
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 Thank you. So let's go. I'm not going to draw the graph because I know that me and drawing are not guys, not in a good relationship. So let me take a screenshot. I will just remove them. I will not share the screen, but I'm assuming that you can draw it. Can I assume that you can draw the graphs now because we did by using points, and later on during the revision we can do we'll draw by using the methods x let x equals to y, let what. Are we all together there?
Yes.
ma'am.
So I do need this.
All together.
Just you want what? Guys, one advice, don't be left behind. Make sure that you go through last week's videos. If you don't understand, move with us, guys. Let's move in the same train. Right? Let's move in the same train. It might be slow, right? I will not mention the name of the trains that are slow. I might get into trouble, but move in a proper with us. If you can see you don't have a ticket, oh, I almost said something. Go buy a ticket. Go buy a ticket, and then catch us on the next station. So I need to take a graph of this. That's why I want a screenshot of the graph that they drew, because it's drawn according to scale theirs, unlike what I'm going to draw me. So we take, okay. Let's take their graph. We're taking their graph. So here we are assuming we are drawing, né? Let's assume we drew. And this is what we drew.
Please
They
share
give
your
me
screen
two.
now.
Yes, I'm still copying. I'm still doing what feels right, but it's wrong. Okay. Here it is. Let's share the screen now. All right. There we go. Ha! I drew it. I'm assuming. Assume I drew it. So the
Ma'am,
first
where's your
question.
reference?
You saying?
Where's your reference, ma'am?
Yes. Slides from Stuart. Recalculate textbook. Yes, Harvard reference. Okay, now the first question, let's enlarge. Yeah, I'm telling you, this is nice. Huh? Look at how it's drawn. Beautifully so. Okay, now the first one says that 2x squared plus 3 is equals to 5x plus 6. What do they mean? What do they mean? What do they mean? They want the graphs where they
Intersect. Equals.
thank you. Simple English, where they are
Intersecting.
equal.
Touching each other.
If you go to crash and say to those little ones, they are intersecting, do you know what they're going to? Where the graphs are equal,
They don't know
What they mean.
right? Yeah, they don't know what intersect is. They want where the graphs are equal. So where are the graphs are equal? It's here. Even not a 2-year-old, but I'm sure a 7-year-old, a 10-year-old, they'll tell you here they are equal because they meet here. So what is that point? Let's see how they are measuring it. Do you see they are measuring using 1, 2, 3? 1, 2, 3. What point is this? Because it looks halfway. So it looks like it's 0.5, isn't it?
0.5. Yes.
Thank you. So it's x is equals to 0.5. And sorry about that. We have chickens. And yeah. And x is equals to 3. That's where they're intersecting. Are we together there, guys?
Yes.
Yes,
Danko.
ma'am.
Danko. Okay, now B. Give me answers for B. This is A. B. They want what? They want what? Oh,
Where the graph
Where
of
the graph or the parabola
Yes.
is under the straight line
where
or
is the?
equals to.
Thank you. Simple English. Where is the graph under the? Where is the parabola under the straight line?
From -half until
Negative. From infinity to
from
Negative half to 3.
Negative half to.
Thank you. They are telling you that they want a straight line where the shark is eating the straight line, meaning the straight line is on top and the parabola is at the bottom. Let's go and see. Where's the straight line on top? Straight line on top, where are you? Oh, it's here. On top, on top, on top. Do you see that?
Yes, ma'am.
So it's between negative 0.5 and 3. But something else. Look at it. What is missing?
Equal sign.
Thank you.
Sign.
They are also equal at those 2 points. Therefore, I need to put the equal sign. So you can also write it like this, negative 0.5 and 3. You guys are getting this most. It means in the assignment you get it. And then number C. What are they looking at? Number C. Simple English, guys. Let's not complicate intersection, intermediate. What?
When the
International.
parabola is on
We're
the
looking
parabola
for when
is
the
on the line.
parabola
Is greater than
is more
the
than
straight line.
the straight line.
Thank you. Because the shark is eating the parabola, so it's want the parabola is bigger than the straight line. It's up. It's on top. Yes, like Cremora. So where is it? Ooh, Cremora, you have to pay me. Where do we start?
From 3 up to positive infinity.
From 3 up to positive infinity. Do we all agree this is the way the parabola is on top?
Yes.
Yes.
And then do we
Not
keep
only-
quiet?
No.
From
Don't we start from
Negative half
negative
to
infinity
infinity.
to negative half?
Negative.
Thank you. When we read in maths, we always start from the negative side when we read graphs. So we're supposed to do what? We're supposed to here. Do you see that? Up to a half. Do you see that, guys? Are you seeing that?
Yes,
Now
ma'am.
that you see it, give me the answers. I can't say yes. Give me the answers. I want answers. I want answers.
It's negative
Negative
infinity.
infinity up
Negative.
to
And
negative
half.
infinity.
Wait,
Negative
there's a
one.
lady who started and said negative infinity. Let's start there. C is negative infinity
to negative half.
To negative 0.5 or from
From 3 to infinity.
okay. Can I use the interval notation, guys? Please help me write with an interval notation. Yay. What am I doing? This is not right. Okay, let's do the interval notation for this one. Let's do the interval notation for this one. It's from what? Let's see.
Open brackets.
Open brackets.
Negative infinity, comma.
Negative infinity, comma.
Negative 0.5.
0.5.
Union. Or, yeah. And then open bracket, 3, comma, to infinity.
But this one I wrote it. Well done. Guys. I need score. You guys are making me happy. We can even do the whole chapter 2 today. I'm joking. I'm really happy. So that's the interval notation. Are we okay now, right? With this?
Yes, ma'am.
Danko. Okay. Now we first define functions f and g that corresponds to the left-hand side and to the right-hand side of the equation. And so we define these are the functions. Next, we sketch the graph of f and g on the same set of x's. Next, the given equation is equivalent to f of x equals to g of x. From the graph, meaning that if you look at figure, that's where those two graphs are equal. And we said at x is equals to 0,5, and I mean, yes, negative 0,5, and x is equals to 3. We were right. And then we say the given inequality, number B, the given inequality is equivalent to f of x less than g of x, since the shark is eating g of x. So we mean that g of x is on top of f of x. And yes, we did get that the interval is equals to negative 0,5 and 3. And yes, this is us, guys. Do you see how we are skipping when we know the work? We just skip everything, slides. That's us, and congratulations to us. Now let's look at increasing and decreasing functions. Increasing and decreasing functions. What does it mean? When function is increasing, decreasing. It is very useful to know. Okay, I didn't ask. No questions from that one. It was explained well and discussed well, isn't it? 3 yeses. Yes.
Ma'am,
Yes.
can I have the graph, we find it there or we have to draw it?
Normally with such questions, the graph, you find it there, because if you draw it and you are just like me, where a human being is drawn like this, then you get it wrong.
Okay, thank you, ma'am.
Well done. Sharp, sharp. Oh, pleasure, not well done. So increasing and decreasing functions, they say it is very useful to know where the graph of a function rises and where it falls. The graph shown in figure 5 rises, falls, then rises again, as well move from left to right. Do you see that, guys? It's important. Left to right. It rises. Okay, let's not look at what they're saying. From here to here, it's going up, 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 isn't it?
Yes.
Up, 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 up. This is up, up, up. Okay, let me choose a different color. Can I choose am I allowed to choose a different color? I think I'm allowed. I need to be allowed to choose a different color. Can we all see yellow? Especially our male. Can you see yellow? Because I know there's what we call color blindness in men. Can you see yellow?
Yeah? Has this been confirmed?
Yes, color blindness is mostly men.
No, we can't.
Okay. Okay. All right. Let's keep it down. So from A, can you see the blue now? If you go up, 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 then the function is what? It's rising.
Yes, ma'am.
Then it gets to B, then the function decreases, it's falling. Then it gets to C, then it rises. That's the rise and the falling and the decreasing and the increasing. So when the function rises, it's increasing. When the function goes down, it's decreasing. Are we all okay and together there?
Yes.
Thank God. So they say the function f is said to be increasing when its graph rises and the decreasing when its graph falls. Sorry, we have the following definition. So this definition just says that if I choose a point x and y on the interval, look at this, they chose x and y, right? Now, if you substitute x and x1 and x2 in the function, and you find that your f of x1 is less than your f of x2, meaning that this point is less than this point, which is true. It means your function is increasing like this. That's what they are saying. Now, they are saying that if x1 is here and x2 is here on this particular interval that you draw your graph, and if you substitute x1 in f of x1 and you find it that that point is higher than that point, it means your graph is decreasing like this. That's what they're saying. That's what this definition is saying. Are we all together?
Yes.
Yes, no.
Yes.
Move forward.
Yes, ma'am.
Okay, now this is a graph that I would not ask you to sketch because it is x to the power of 4. So I'm assuming it will need a graphing calculator. If it was me, I'll do the same. So we'll skip this example. Skip, skip, and skip. Local maximum and minimum. Local maximum and minimum. Let's talk there.
Turning point.
Turning point.
Yes.
Good.
Yes.
No.
But if I have a graph like this, Where's the local maximum and minimum? Okay, I'm assuming this is a turning point. This is A, this is B, this is C, this is D, this is E, and this is F. Where's the local maximum and minimum?
From A to B is the local.
From A to B.
Local maximum.
Local maximum is F, C, and E.
Yes.
Then local minimum is B, D, and F.
D, yeah, F, yeah, good. B, D, F.
The local maximum is the highest point in a small region. The local.
Continue. You're not done, Pen. Local minimum is there?
The lowest point in a small region. I'm not sure if I'm correct.
You are, but why are you doubting yourself? Guys, what does local mean? And don't say local means lekker. Aye. What does local mean? So when you're looking, yes, around a particular region. So now when you're looking at, for example, this graph, there's a lot of local maximum and there's a lot of local minimum. Does it make sense? Or someone is lost?
I'm lost.
So this is the local maximum here. This is a local maximum and this is a local maximum. This is a local minimum and this is a local minimum and this is a local minimum.
Good.
Makes sense. Because in this region here, this is the maximum. In this region here, this is the minimum. In this region here, this is a maximum. In this region here, this is a minimum. That's why it's called local maximum and minimum. Now, if you want to find the maximum of the biggest of them all, it's called the absolute maximum or absolute minimum. So once you talk about local maximum, you're talking about the following. They say finding the largest or the smallest value of a function is important in many applications. For example, if a function represents a revenue of profit, guys, when you're looking at profit, where do you want to be? Maximum or minimum?
Maximum.
Profit. Maximum. Whoever is looking for minimum is doing charity with their business. So for example, in a function representing revenue of a profit, then we are interested in its maximum value. For a function that represents cost, you want the cost to be minimal value. We can easily find these values from the graph of a function. We first define what we mean by local maximum and a local minimum. So they are saying that local maximum and minimum of a function. The function value f of a is the local maximum of f if f of a is greater than f of x. Meaning that if I choose a here, right? This is a and we call it f of a here. Do we know that any value is represented by the value of x, isn't it? The value of x just represent any value. Meaning that these values of here, we can represent them using x. All of these values here, up to, let's say, this point, we can represent them using the values of x. So if you take this and substitute in f of x, and you substitute x, you still get what? You still get x. Do you see that? Are we all together, or I'm confusing someone?
I'm confused.
Can you repeat again?
I'm saying that if we say this value here over here is a, you see this value here on top here is a, right? It means that we went and took a and substituted in f of a to get what? F of x to get a, isn't it? Right? Now, because these values that are here, between, let's say, up to this point here, right? Between here and here, we don't know the values there, isn't it? But we know that those are x values, isn't it?
Yeah.
So meaning that these values are represented by f of x. Now on this region here, which one is greater? Are the values of f of x greater or the value of a greater?
The
In
value
that
of A
region.
is greater.
Then it means it's either greater or equals to, they say that like that, meaning the shark will eat that. So they're saying that if the value that we chose is greater than all the other values there in that region, it means that is the local maximum. That's what they're saying here.
Okay. Okay, ma'am.
All the values
get
that
it.
are near A. Meaning that if I choose now, let's go to the next region, this region over here. You see, if A is here, do you see that the x values, this x value is greater than A, and this x value is greater than A, and this x value is greater than A, meaning that f of x will be greater than or equals to f of A at that particular region. So meaning that that's a local minimum. That's what they say. So if you're looking at this graph, this is a local maximum, this is a local maximum, and this is a local minimum, and this is a local minimum. But because your graph is continuous, you cannot say which one is the absolute maximum or minimum, because you don't know that at x is equals to 1 million, your graph maybe is doing this again. Do you see that? So we can find the local maximum and minimum of a value of a function using a graphing calculator. So we're talking about graphing calculators as well. So we're not going to looking at that. But here they're telling you this is your local maximum and this is your local minimum for this particular graph here. So this is the graph, local maximum here, local minimum there. And we won't look at it because this one is using a graphing calculator. And that was the second session. Any question regarding the work? If there's no question regarding the work, then I can remove the recording. Okay, should I stop the recording?
Ma'am?
Yes,
Ma'am,
regarding the work first.
I do have a question, but it's for inequalities.
Graphical.
No. It's not for the section that we're doing. It's just a short question.
So what? You suggest we record, not record? What do we do?
I don't think you can stop recording now. Fine.
What's going on with inequalities?